In this last video of the section, we're going to be talking about the remainder theorem. But before we do that, I want you to try this example here. You already know how to evaluate functions given an x input value. So you'd plug that in for x everywhere you see it and use order of operations to simplify. And we should already know how to do division, synthetic division, based on the last video. So we're dividing this polynomial p of x, or function p of x, by x minus 3. So just take a moment to do these two problems and then look to see if you notice anything about parts A and B. Let's talk about this example. So we have p of 3. This means that we are plugging in 3 for x everywhere we see an x. We follow order of operations. I start with my exponent. 3 times 3 times 3 would be 27. Then we would multiply. 3 times 27 is 81. And 7 times 3 is 21. Then lastly, we add and subtract. 81 minus 21 is 60. And 60 plus 1 is 61. Alright, so that's part A. Part B says use synthetic division to find the remainder when p of x is divided by x minus 3. So we're taking p of x, so this function, dividing by x minus 3 using synthetic division. So first we identify c. C would be positive 3. I fill in my coefficients. So x cubed, the coefficient was 3. There were no x squareds. Negative 7 is the coefficient to x, and 1 is the constant. I bring down that first term, coefficient. Multiply. 3 times 3 is 9. 0 plus 9 is 9. 3 times 9 is 27. 27 plus a negative 7 is positive 20. And 3 times 20 is 60. And 60 plus 1 is 61. So it said to find the remainder. Remember that last number is the remainder. So the remainder was 61. Do we notice anything about part A and part B? Well, it is that remainder, that idea. So when I evaluate p at 3, I got 61. And the remainder, when I divided by x minus 3, was 61. So that's exactly what the remainder theorem says. It says if we have a polynomial divided by x minus c, then the remainder is p of c. So let's go ahead and look at this example and try it. It says use the remainder theorem and synthetic division to find p of 2. So notice that p of 3, we used 3 in our synthetic division. So p of 2, 2 is our c. So 2 is my c. And then I'm going to use synthetic division. So coefficient to x to the 5th, coefficient to x to the 4th. There were no x cubes, no x squareds, coefficient to x, and my constant. I bring my first coefficient down. Multiply. 2 times 6 is 12. Add. 12 plus a negative 4 is 8. Multiply. 2 times 8 is 16. Add. 0 plus 16 is 16. Multiply. 2 times 16 is 32. Add. 0 plus 32 is 32. Multiply. 2 times 32 is 64. Add negative 40 plus 64 is a positive 24. Multiply. 2 times 24 is 48. And add negative 10 plus 48 is 38. So that means, based on the remainder theorem, that P of 2 equals 38. Now we could check that by plugging in 2 if we wanted, but as you can see, 2 to the 5th, 2 to the 4th, we're going to get some large numbers here. And so for all of this, I could multiply and add all of those numbers in my head, and it was actually faster than evaluating. But that's what the remainder theorem says, is if I want to know P of 2, then 2 becomes my C, and I use synthetic division. That last number is my remainder, so P of 2 equals that remainder.